Eckhard Briedenhann and Robert Bennetto, and both of them are from CHELSIT. So they will be talking about reference classes, an antidote to complexity.
Cool. Hi, everyone. I'm sorry you have to hear from me twice today. This one's slightly less charged. Who here gets excited about reference classes? So excited they feel the need to write a presentation about it for satRday? Excellent. Good. We're all on the same page. This is not. This is kind of like the grenade potato of topics. You really don't want to talk about reference classes. It's very difficult to make it fun. So I represent one end of the topic. Eckhard represents the fun side of the topic. That's not completely true, though. Cool. So we're from a company called CHELSIT. We distribute IcePack services. They're a company that does AI and machine learning services. It's pretty cool. We do a lot of consulting and operations research with a specific focus in Africa, mostly in the insurance and logistics sector. That is how I'm planning to spend the rest of my weekend, given that this week consumed the satRday presentation. Cool. A little bit too much information. Eckhard, over to you.
Cool. What's up, my Joburg homies? Zebra in the house. So, thank you very much. So, I know what you're all wondering. Why do I have a yellow shirt, a tie, and a zebra costume? Well, I've been told that yellow is my color. I wear a tie because I'm not an animal and I want to be professional. And as for the zebra suit, well, we're going to have to backtrack to the beginning of last week, where I got a calendar notification telling me that I have a talk today, to which I replied, whoopsie. You see, Rob and I both forgot this, and I kind of started hyperventilating. I thought, okay, well, maybe let's just think it through. So what things do I need to consider? Well, firstly, there's what to wear. I mean, do I go normal? Do I go formal? Do I go zebra suit? I mean, there are a lot of decisions, and not entirely clear which decisions are the right decisions. And then, how do we fit it in with all of our other responsibilities? Because we've already planned our week. I mean, do we have enough time? How long will it take? What do we do first? Do we start with the presentation? Do we start coding and hope that the presentation takes care of itself? Do we just go cry in a corner somewhere? Sorry, I have a bit of PTSD. Give me a second. Well, being an engineer, I thought, okay, well, how do I over-engineer this solution? So let's start off with what I need. I need a way to represent states, so like being in a state of being awake and being in the state of having a zebra suit on, or being in some other state, and then the transitions between these states. So if I can find a way to represent the states and the transitions between them, and then I weight these transitions somehow with the times that it takes to put on a zebra suit and to get to the talk, and then maybe get an algorithm to output the metrics to what the optimal decisions are, then maybe we have something. I like this. This is structure. Structure is safe. Scientific even. I like it. So I thought, I heard Rob talking about a graph at one point, and I thought, yeah, this could kind of work. I mean, we have a set of states defined as nodes, and then we have the edges connecting them. You could weight the edges. They could be directed edges, because you go from one state to the other. You can't go to the Gautrain station before putting on clothes, because that'd be a bit weird. Might excite a few people. So the process would be, and I explained this process to Rob. I told him, Rob, we create the states, we assign weights to the transitions, and then we create the metrics of the related graph. So then we have some way of making decisions. It's not just vague. And as I was saying this, I saw Rob just going into his zone, calculating stuff. And he told me, Eckhard, you need a DAG. I was like, a DAG? You're my dog, Rob. It's like, no, Rob. No, Eckhard. You need a Directed Acyclic Graph, or a DAG if you're a cool nerd. So basically they have nodes, and they have directed edges, and they have no cycles. Hence the name, Directed Acyclic Graph. Which is great if you don't want to get into an infinite loop, and then you have to wait for the heat death of the universe to come by to help you out of it. And it basically looks like this, where you're always moving in one direction, the different nodes feeding into each other. Very nice. So I thought, okay, how do we do this in R? Well, let's say we create a node list, and the nodes are defined as lists themselves. So we have that whole listception thing going on here. And then we assign IDs, just as a POC. Then we maybe have to have some helper functions to extract the nodes from there. Yeah, it feels messy, but okay. We could use a vectorized graph, so you know, like a data frame that looks something like this, where we have all of the from to pairs. But yeah, I don't know. Can you smell that? It's maybe just me. It's probably the suit. Didn't wash it in a while. Or we could do the listception thing again with the graphs as well, where we have lists of lists, and then we store the adjacency pairs for every node. So for node 1, we have all the adjacent nodes to it, and then go like that. But I don't know, all of this, yeah, it looks like that, not formatting, you didn't see that. But I don't know, it all smells a bit So what would be a better way to do this, and why does it smell funny? Well, there's no typing, so we live in the Wild West, because you could just assign anything. I mean, Rob could decide to use characters, I decide to use numerics because I'm cool. And there's no standard as well, because there's no way of creating the nodes. I mean, everybody just does whatever they want to, unless you have some kind of explicit framework where you agree upon all of the developers who will be using these constructor functions or whatever. And also, there's no abstraction. So you see all of the lower level mechanics, and it's very verbose, and you have to do a lot of index hunting, because some of the data might be on one list, the other one might be somewhere else, and that's just very messy. And, you know, ain't nobody got time for that. So what would be a better way of doing this? Well, in the C++ world, they have this thing called object-oriented programming, where you essentially create object classes which have all of the different properties relating to that object. So you would have a node class, and then you could create a graph class, and it knows how to add nodes to itself and do all of the funky things. So then, in practice, you only initialize the nodes, and you add them to the graph. And then you can call functions of that graph. It's nice and pretty. I like it. So please tell me we have something like this in R. And now I want to play a game called Rate That Object-Oriented Programming Framework in R. I agree the name needs a bit of work, but no. First up, we have S3 classes, which I like to refer to as basically a poor man's version of classes. What the R people did is they said, okay, well, we have this thing called a list. It's kind of like a class, so maybe let's just add an attribute to it, call it class attribute, and there you go, you have a class. It's like, okay, it works. And then you can create like class-specific functions. So here, if you say print.node, it will then overwrite the default print function, and then you can just say print n or n1, and it will actually do whatever you specified there. So the benefit to this is at least you have some kind of structure. I mean, it's technically, I guess, some kind of form of a class. And that model or class-specific function might be useful. I can see places where you might be willing to use, or that could be exactly what you need. But it doesn't feel like it's the right fit for what we want to do. So I'll give it a license solid 5 out of 10. Next up, we have S4 classes. One number up. It's getting hectic. So you basically define the class as a node class, and then you have slots. It's getting nice. There's some typing there, numeric. I'm liking this. And then you have a constructor. So you just create a node with ID 1, and then the same print semantics. So the class-specific functions also count there. So it's nice, yeah. It's also, I mean, it's not bad. So benefits, I mean, you have some typing, which is not bad. A structured way of creating and interacting with objects. Even though you need to use that dodgy @ symbol, because it's slots, it's not actual members on the object. I don't like it. If you're a cool kid, you use the $sign, but okay, it's something. So overall, 8 out of 10. But now we get to the real star of the show, the reference class. And this is where you clap hands. Yes, Joburg. Thanks. I like your enthusiasm. So reference classes basically have the best of all the worlds, where you are able to define the class. You can set a bunch of fields. You have then you can also set a method list where you can incorporate all of the methods specific to this class as well. And then if you print, the print function actually calls, by default it will call this show function on a reference class, and then you get the pretty print, a printed version of that node. So the benefits is, are that unlike the S3 and S4 classes, the methods are specific to the actual object. So it's not some kind of outside function that you now call and you hand it this and you're hoping that it knows how to execute it. You actually execute it off the object. So let's say you have like a node and you had myPrettyNode function. You would say $ myPrettyNode function, it would just execute it, which is nice. It's a nice way of thinking about things. And you are able to have like a pointer-like functionality, which is something you see in C++ a lot. So I'll talk about this just after this slide, but that's also something nice. And it's a powerful abstraction layer, because now you don't need to know about any of the lower level semantics. You can just go ahead and create your classes. So overall, 10 out of 10. So you had my curiosity, but now you have my attention. So basically, there are a few things you need to note. Under the hood, it's basically an implementation of an S4 class wrapped in its own environment. So it looks something like that. So every instance of the reference class has something like that. And variables are references to objects and not the actual instances themselves, which is something you see in R most of the time. So just to explain that, if you are copying a reference class, normally the way you would do it is you would create a node, and then the wrong way to copy it would be the way you would normally do it. You could use the assignment operator. But now if you change, let's say you create a variable called n2, and now you change n2's ID, that will also change n1's ID. The reason being, okay, this is cut off, but the reason being, they're both pointing to the same instance under the hood. It's a reference, it's like a pointer. So it's the same instance under the hood, and they're both pointing to it. So if you're changing n2, you're both changing n1 as well. The right way to copy it is to call the copy constructor, which will then create a deep clone of the object. So yeah, there you see it. It's not actually impacting n1 if you change n2. And then the fun stuff.
Thanks, Eckhard. I'm trying to remember what this was. Oh, yeah, now I remember. Okay, so why reference classes, right? I really like having neat, clean code that, and one of the other, the guy from Netstar, hand up, yeah, your presentation spoke to me, man, because all of a sudden you're looking at really simple code that's at the right level of abstraction. If your code looks simple, you've probably hit the nail on the head in terms of how to model something, right? So if we're talking about like a graph, for example, and we want to do this using reference classes, I want to be able to do something like this. I want to say, create a DAG, put it in G, tell G to load from a file. So let's say I've got a file format that I've specified, and it's going to load that data into G. It's not going to go into a global scope for your R session. All the data is actually going to live inside G, its own environment. And then I can tell G to plot. And this is what my plot looks like, right? It's kind of neat. You're going to say, classic BST, Rob, you lied to us. That's not a binary search tree. I say, yes, it is. You just have to project it correctly. So that's exactly the same data with a different layout, right? Which is pretty neat. So I've got a function called plot hierarchically, right? Because why wouldn't you? You want to try and abstract away all that complexity just into a set of functions over your objects, right? So I might want to highlight some features. So for example, that node at the top there says submit talk, I think. And then all of these nodes at the end are how are we going to actually end up presenting this talk. And so you can see now I can easily see what are the leaf nodes, what's the root node. Yeah, we can see where this is going. Cool, so I've got a function that says color root and leaf nodes. That's cute. We can reproject it. We can plot it unhierarchically with the same parameter. You just inject it in, and the class knows how to plot it now, right? So these are cool things. We might want to modify the structure, right? So let's say, all I've done here is just said I added another parameter called turn. So you can see I'm trying to get everything into a one-liner, right, where I'm ultimately injecting all of the complexity behind the scenes in the object so that I can reuse it in lots of different places, right? So I've added a thing called turn, and it's turned my whole binary search tree on the left. And what I want to do is I want to close this graph out, right? So I want to say, sorry, I should have actually primed these nicely beforehand. I want to connect all of those leaf nodes down to one root node, right? And I want to close out this whole graph. So I've got one start node, one end node. And for modeling purposes, this is really nice. So I've got close the graph, create, and then just plot the hierarchy again. Again, nice two-liner, really clean. You can see exactly what I'm doing, right? Okay, cool. And now we want to do some graph search. We want to say, I want to get from determined topic to present at satRday in some kind of way, right? So let's say, for example, we could be doing the shortest path, we could be doing critical paths, you're doing all kinds of different min-max cuts. So if you want to do a sensitivity analysis of the graph, there's lots of features that you might want to interrogate about this graph, right? So I created a function called shortest path from basically A to B, so from my leaf node, from the root node to the end node, right? And so now I can plot my shortest path in my graph to get us from A to B. And some of you with really keen eyesight will see where we're going with this. But you might want to plot the critical path. So same plot, but you can see that we're no longer intersecting through that route. We take that route. It's quite different, I think. And so remember, each of the weights on this graph is actually different. There's a whole bunch of different features that we've looked at. So we're trying to quantify what the best way is to actually deliver this talk. So right, that was very quick. What happened? Basically, I didn't show you very much R code, but what we did was we used the R reference classes to create a layer in front of all of our data wrangling. There's lots of data wrangling when you deal with graphs. And we're actually using RCPP behind it because I feel like I can't give a satRday talk without mentioning RCPP anymore. So we've got an R layer up here and the CPP layer over here because we don't really want to reinvent the wheel. We want to try and leverage as much of the stuff that's already there behind the scenes, right? So you'll argue this is overkill. I say no, this is just the right amount of kill. We didn't reinvent the wheel. There's a lot of complexity when it comes to graphs, extracting features consistently. The actual algorithms themselves are quite complicated, and you don't want to be retooling those either, which brings us to the zebra suit. So this was the shortest path, and if I can just, so effectively this is, this is present at satRday over here, and you can see we had to come through the zebra suit as our path. We had to talk about Viz Network, Shiny, R Markdown, and RCPP. So this pretty much ticks all the boxes. There are some other very interesting paths that we could have taken to get there. If you're delighted to see what those were, you should check out the repository. I'm not going to show you all the code, but there's some horrors there. Eckhart's very lucky he's wearing clothes at all. If we'd gone with the critical path, this would have been a nightmare. Yeah, so that critical path would have put him in a dino suit. So, but he didn't own a dino suit, so we were quite lucky. Yeah.
Yeah, so basically all of this code will be available on our repository. And this is the Overengineering 3000 stack. This is how you overcomplicate this problem. Basically, what we've showcased is reference classes, created nodes and DAGs using that. We've implemented RCPP algorithms, shortest path, and Rob implemented a few funky ones. We're using D3 for some of the visualizations, but I think it's using Viz Network.
Which wraps D3?
Yes, yeah. And bonus round, this whole presentation is done in RPres and embed active charts.
Yeah. Oh, so I'll explain this quickly. RPres by default doesn't let you embed HTML content directly, but you can easily put it into a pre-processed script and then serve everything up through an iframe. So if you'll get a nice compiler error when you run knitr on these sorts of charts over here, which can be very frustrating to people who don't know like how to actually do this. So if you want a kind of like a reference class or reference, I don't know, a reference card of how to actually execute some of the more complex stuff, this repo, we kind of went a little bit too wild here. We decided to stay completely with R, and this is actually really annoying to get right. So if you want to save some time and have cool presentations where you can interact with your data and still keep it all in the RPres framework, it's a neat way to do it.